Hello guys, welcome back. Today we are here to learn a new question called majority element. Question number 169 from lead code. So let's go through the question, let's understand this. So given an array nums of size n, return the majority element. So what does the majority element means here? Let's see. The majority element is the element that appears more than n by 2 times. N by 2 times. You may assume that majority element always exists in the array. Okay. So they're saying that we have given us an array, and from this array we need to return a majority element. Majority element. And that element will be more than n by 2 times. Let's say if you have 7 elements, n by 2 is something called 3. So majority element is nothing but the element which is greater than 3. Like obviously the element will be repeated 4 times at least in the array. The element will be repeated in this 7 size array. It will be at least 4 times. At least 4 times the element will be there. I hope the question is clear. Let me give you one example and let's see that one. So for example, nums 2, 2, 1, 3, 2, 4, and 2. If you observe, what is the majority element here? What was the majority element, guys? Yes, the majority element is 2. Why? 1, 2, 3, 4. It was being there 4 times. And what was the nums size? 1, 2, 3, 4, 5, 6, 7. 7 by 2, 3. And 2's, 2's count is 2's count is greater than n by 2. So this is the majority element. This is what we need to find out. So for this question, to find out this one, there is something called as Bois-Moore algorithm. Okay, there is an algorithm called as Bois-Moore algorithm. So this algorithm will help you to solve this particular question. Okay, solve this particular question. So let me clean this one. The algorithm is Boyer-Moore algorithm. Okay. Now this will help you to solve this question. But what is this algorithm about? What exactly it do? So how this algorithm works is, as we know, majority element count is greater than half of the array. So it means if you have a 2 4 times, okay, the majority element should be greater than n by 2 times. So what it assumes is, like, let me give you how it actually works, guys. So let's take an array 2, 2, 1, 3, 0. Let's take okay, this is your array. So what happens is, there are two things in this particular algorithm. One is candidate, one is count. Initially everything is 0. So now your algorithm starts. It will go to this particular place. The value is 2. So what it do is, initially everything is set to 0. What it will do is, it will update the candidate. What is the current candidate? Who is the current candidate? The current candidate is 2. It will update. It will update. After that, as this is the first time we are coming, count will become 1. Count will become 1. Now I'll go to the next value. Value is 2. Is this same as the candidate? Yes. What it will do? It will increase count to 2. Now it will go to the next value. Now 1 and 2. Are they same? No. In this case, what your Boyer-Moore algorithm does, it will decrease the count. It will decrease the count. It will become 1 again. It will become 1 again. Again, we will go to the next value. Again, we'll go to the next value. It is 2, which is equal to your candidate, which means this will update the count to 2 again. This will update the count to 2 again. Next, you will go to 0. Next, you will go to 0. Here, if you observe, is this your candidate? No. Count will become 1. Count will become 1. Now, if you observe, at the end of complete array, in your candidate variable, you have 2, which is your answer. Which is your answer. You might be thinking, okay, this is your first value. That's why we got this one. It's not working that way, guys. How this actually works is, as we know, two instances more than n by 2 times. Okay, more than n by 2 times. Every time we will take one value. If it is already equal to the existing one, we will increase the count. If not, we will decrease the count. And in that way, it works. Let's take one more example. 1, 0, 3, 2, 2, 2, 2. All the 2s are at the end. So now what happens? Initially, who is candidate? Who is candidate? Candidate is no one. And after count is also 0. Now, I went to the first value. What is the 1? 1 is the value. So this will become 1. As this is the first one, count will become 1. Okay. 1 is the candidate. Value is also 1. Count is also 1. Now next you will go to 0. When you visited 0, okay. What is the count? Count is 1. Count is 1. This means this is not the candidate. But is it same as the candidate? No. 0 and 1 are not same. So you don't increase the count. But decrease the count. Decrease the count. Why we need to decrease? What was the purpose of decreasing the count is this helps you to understand, like here this is +1, this is -1, which means there is 1 which is repeated one time, there is 0 which is repeated one time, where they got negated. They got negated, guys. Negated. I hope you know the meaning of negated. Okay. So now count is 0, candidate is 1. Next we'll go to 3. As count is 0, this can be your candidate. So update this with 3. Okay. Next we will go to 2. And 2 and 3 are not same. Count will become again 0. Count will become again 0. Next we'll go to 2 again. Whenever you reach a 2, count is 0, you'll update the candidate to 2. Again you'll go to 2. As count 2 and 2 are same, candidate and current value is same, increase count. Again you'll go to next one. Candidate and count are same, increase the next one. 2 is the value and 2 is your candidate. This is how your Boyce-Moore algorithm work, guys. This is how your Boyer-Moore algorithm work. I hope the algorithm is clear. Very simple algorithm. Like if it is matching the candidate, increase the count. If not, decrease the count. Whenever the count became 0, update the candidate with new variable, new array element. That's all. This is how your Boyer-Moore algorithm works. Apart from this algorithm, we can also do something. One more thing, guys. As they said, 1, 2, 2, 3, 0. Sorry, 2. As they said, majority element will be more than n by 2 times. Sort this array. 0. Sorry, not 0. 1, 2, 2, 2, 3. Okay, 1, 2, 2, 3. You keep on increasing the count. Count for 1. Next count for 2. Next 3. As you know, here itself, you go to this variable 1. What is the count? 1. Okay. Next you will go to 2. This is a new value. Previously count is 1. Okay. So this is not greater than n by 2. So this is not your answer. So next go to, whenever you encountered a new value, reinitialize your count to 1 again. Again go to next value. 2 and 2 are same. 2 and 2 are same. Previous values is same. So increase the count. Again you will go to 2. Previous value is same. Increase the count to 3. Now check. And again you go to 3. Whenever you go to 3, 3 and 2 are not same. Which means this is a new value. 3 is a new value. 3 is a new value. In that case, what you need to do? You need to initialize count to 1. But before doing that, what is the previous count? 3. Is your 3 greater than n by 2? What is n value? 5. 5 by 2? 2. Yes, 3 is greater than 2, which means 2 is your answer. 2 is your answer. This is what we can do, guys. But the time complexity is n by 2 there. But using your Boyer-Moore algo, time complexity is we go of n. So let's write code for this. Int candidate equal to 0, count equal to 0. Now we will have a for loop, int I equal to 0, I less than num dot length, I plus plus. Now if count is 0, which means candidate will be nums of I. Current value is candidate. Okay, if your candidate is matching with nums of I, if they are matching, what you will do? If they are matching, increase the count. Count plus plus. If they are not matching, count minus minus. That's all. At the end, return candidate. No need to worry about if not what happens. It will definitely have a majority element. Don't worry about that particular situation, guys. Let's run this. That's all, guys. This is how you solve this particular question. I hope the question and code are clear to you people. This is one way of doing without doing any sorting and all, without by using the Boyer-Murray algorithm. That's how the algorithm is. Don't worry about this one. I hope the question and approach are clear. Let's meet in the next video. Until then, see you guys.